Morning girls, we are continuing our topic on C6. This is lesson 3, extraction of aluminium. Today we're going to be able to explain the process of how aluminium is extracted, to write down the half equations, and then to state some uses of aluminium. Now if we look at our reactivity series, we can see where aluminium is. So why do we use electrolysis? Okay, that's because aluminium is more reactive than carbon, therefore it cannot be displaced by carbon. So remember, when you're answering your questions, always using those keywords. The raw materials we have is we use the aluminium ore, which is called bauxite. Now this ore is made up of aluminium oxide and some iron oxide. Furthermore, we add cryolite, a mineral called cryolite added to it, so it lowers the melting point. Now often in the exam they will ask you this question on why we add cryolite during electrolysis. Okay, so remember, that's to lower the melting point, and that could be to save energy, because remember, electrolysis uses a lot of energy. So here you have the electrolysis cell. Now you can see this is quite different from the ones we did in last lesson on electrolysis. Some things are the same. So you got your anode and your cathode. This is made up of carbon, so your carbon anode, carbon cathode. Your electrolyte is molten aluminum oxide with the cryolite dissolved in it. Again, remember why it needs to be in the molten state. Okay, so thinking about that, so that the ions can move. And next thing you have here is a steel case that it's in. So that's your steel case around. Now you might be asked in the exam to label this diagram, so you do need to know this. So how does electrolysis work? Here you can see the formation of the ions from aluminium oxide. So you have your Al3 plus and your O2 minus, and because it's in the molten state, you have the ions here. You have O2 minus and your aluminium 3 plus. Let's look at the reaction happening at the anode. So what do we see happening at the anode? You have the negative ions coming towards the positive anode. These lose electrons and you have oxygen gas which is formed. Okay, let's write out the half equation. So let's try and understand this. This is where we left last time. So here you have oxygen, O2 minus, forming oxygen gas which is O2. If I write this in terms of the atoms, I've got 2 atoms of oxygen. Okay, and to balance the equation we put a 2 here. Therefore on this side of the equation you have 2 of all the oxide ion, O2 minus. Okay, and then you can see because the charge is -2 and -2, that makes it -4, so we have losing 4 electrons, and that's how we balance the equation. Now one step further, that's your half equation. Now because the anode is made of carbon, the oxygen further reacts with the carbon, releasing carbon dioxide. Okay, so this is another step that you need to know. Let's see what happens at the cathode. The cathode is negative, so we're going to have electrons being gained by aluminium 3 plus. How many electrons does it gain? It's got a charge of 3, so it gains 3 electrons, forming aluminium, okay, atoms in the form of a liquid. And here we have the half equation. Again, we're balancing out, so you have to put the 3 there. Remember, your charge is 3, so you balance it out and you have 3 electrons. A quick review of what's happening. Negative ions going towards the positive electrodes, releasing oxygenous form which combines with the carbon and forming carbon dioxide. At the negative cathode, we have the aluminium ions which are going to gain 3 electrons and form aluminium, which is in the liquid form. And here is a summary of what happens at the 2 electrodes. And finally, some uses of aluminium. Here you have all the uses. Now you might know the uses, but in the exam you always need to write down the properties as well. Uses. Finally, our next steps. You need to complete all your questions in your workbook. And I will see you tomorrow for MS Teams meeting. And stay safe, girls. Take care. Bye.